With a screw compressor, we've got two methods of being able to control refrigerant through it, which means our capacity, being able to stage it up and stage it down. Now, if you're not familiar with what a screw is, it's literally taking two bolts, we call them screw bolts, you have a male and a female, that insert into each other and they spin simultaneously to create direct compression. Pretty incredible technology, been around for a long time. A lot of people doubted it in the early days. Now it's taken over the industry. Sounds kind of familiar to some other stuff we know. How you doing? I hope you're having a good day. I am Holden Schamberger. I'm with HVAC Time and Chiller Academy. My main specialties are chiller systems and VRF. Chillers are by far my main thing, and that's what we're here talking about today is a screw compressor in a chiller. We have two very distinct types of loading control or capacity control with a screw compressor. The most common in the OG, the original style, is using a slide valve. This is part of what I have here behind me, by the way. So this is a slide valve out of a train. Part of what we're doing with the slide valve is we're changing how much of the screw bolts can get used. So when the slide valve is at 100% position, that means that our entire length of our bolts is creating direct compression. But we can slide this valve over, and as it slides, we are changing how much of the bolts are actually compressing. The portion of the bolts that get uncovered no longer are able to make compression because it's just kind of released and open. So when the slide valve moves to a fully unloaded position, there's still direct compression happening, but it's just a very minimal amount, and it may only be 10-20% of what that compressor's actual volume is capable of moving through it. As that slide moves and increases or decreases capacity, it's also increasing or decreasing our current load through the compressor. That is one of the main methods used to control how much we are going to stage up or down is what is our RLA. So we're going to run based off of percentage of RLA. So if we've got a limit of 100% of the compressor's amperage, that valve doesn't have to be at 100% to meet that RLA standard. Depending on the refrigerant and the load conditions, we may see a high RLA with that valve only at 75% position. And it doesn't mean that there's something wrong, it just means there's a lot of load. And we have to manage that load on the motor as these bolts are trying to do work. Now, typically, the other main value, the set point that it's trying to stage up or why we need to increase or decrease capacity is based off of leaving chilled water. If we need to increase capacity to make chill water set point, then we've got to slide this valve over to put more refrigerant through the bolts in order to increase capacity. So the leaving water set point and the current limiting set point both have to work in unison together, which they usually, unless there's a high load or there's something wrong, they rarely have that much conflict. But these two variables are what dictates what that slide valve gets to do at the end of the day. Now, the second style, and it's going to be the more common thing moving forward, is variable speed. Instead of having a slide, we'll have a variable speed drive run that compressor up and down in order to just increase the physical RPM. By increasing or decreasing the RPM, the speed that the motor is spinning at, we're able to change how much refrigerant flows through it that way. Now, we still have the RLA limitations and trying to meet our leaving water set point, so those two things still have to balance just the same. It may be a 60 hertz motor. We may be at RLA at, say, 40-50 hertz depending on our load conditions, and we may not be able to run at that 60 hertz and still safely control the motor. So these are things we have to balance still. That's not removed from the equation. It is uncommon in my experience to see these two put together, and I'm only aware of, at least off memory, I'm only aware of one compressor that actually combines these things, and that is the vertical screws used by Dunham & Bush. And how they're controlling it is during startup and shutdown. So in the startup phase, that slide valve in the compressor will be at minimum load, and the drive, those use Danfoss drives, will start off at a minimum speed, and that'll help get the compressor spun up and off the ground. And then when the compressor gets ready to start loading, the first thing it does is it immediately moves that slide valve to fully closed position, meaning it's allowing the maximum amount of refrigerant through the screw bolts, and then we will start to vary our drive. So that's where I've seen them used in unison. It was either this is typically the startup and shutdown phase to unload the bolts more than what the drive can do to just help with the whole process and improve the overall function and efficiency. So those are your main types that we use today in order to control how much we load or unload a screw compressor, and some of the variables that we have to go through for that. If you're interested in more training like this, go to chilleracademy.com. I've got courses on there that'll help take you through just learning what chillers are, chiller systems, and building yourself from the ground up. I know I had a really hard time with it. I created this academy and these videos to really talk to myself at that stage of my career when I didn't have these resources available to me. Either way, we've got them now. MTT, make the time for your family, for your spouse, for your kids. They really need you.